everybody. Thank you, Stuart, for such a kind introduction. I am very happy that I was asked to present this year. Why is this already doing this? Sorry, this isn't supposed to automatically go. So without further ado, I'd like to present the Revered Mount Wilson Observatory yesterday and today. So this is sunset from Mount Wilson. I took this before an observing session on the 60-inch a couple years ago. And as many of you know, Jack, Steve, Wayne, those of us who have lived in Southern California, it is lovely, but there can be some drawbacks too. Two things of which, smog and traffic. However, all of that smog can make for some lovely, lovely sunsets. This is looking towards the cities of Glendale and Burbank, and Todd and I lived in Burbank for many years. And, sorry, I don't know why it's doing this. Griffith Observatory is visible in this view. It's very difficult to see, but where that arrow is located is where Griffith looks, from Mount Wilson. And you can see more smog here. This is from the top of Mount Wilson, again, looking right at downtown Los Angeles. Jack knows this view very well. If you look closely at this picture, though, off to the right, you can see the marine layer coming in from the coast. And there were nights that it would come all the way in 35 miles and sit right below the summit of Mount Wilson, which was at 5,715 feet. And the skies would get very, very dark. Probably not as dark as they get here in some of our darker spots, but it would really, really help with the light pollution. Now this is a view looking directly east at Mount Wilson from Pasadena, and the observatory is located right there. There are some radio towers over to the left, so if you are ever able to visit the LA area, you can find Mount Wilson by looking for those radio and those TV towers. So, I know 5,700 feet doesn't seem very high to us, those of us who live in the Mile High City, but the San Gabriel Range really towers over the entire LA Basin area. The observatory is located, obviously, like I said, in the San Gabriel Range, and that encompasses about 346,000 acres. And this was designated as a national monument in 2014. So it actually does provide some environmental protection to the region, which is sorely needed. The first inhabitants of this area were of the Tongva tribe, and at their height, they were about 5,000 to 10,000. And they also lived on the southernmost Channel Islands as well. So Spanish exploration, sorry, is there anything I can do to stop it from doing this automatically? I'm not even touching it, and it's advancing.
It's a computer.
Okay, we'll just try and stick with it. Yeah. So Spanish exploration of the area first occurred in the mid-1500s, and by the 1700s, unfortunately, the population of the Tongva were completely decimated due to the diseases that the new settlers had brought with them. So the first exploration of the mountain was by this gentleman. There we go.
There he is.
There he is. His name is Benjamin Davis Wilson, and surprisingly, in the research that I did, he was the grandfather of George Patton, which I found was a little strange but interesting. His nickname was Don Benito, and he ran a winery in what is now known as San Marino, which is just a little bit south of Pasadena. And anyway, he would go up into the mountains and he would look for wood that would be suitable for his casks. He wasn't ever able to find suitable wood, but he did build a trail going up Santa Anita Canyon to the top of Mount Wilson, and that's why Mount Wilson is named after him. During the late 1800s and early 1900s, this was a tourist destination, and there were many camps and beautiful cabins built up there. And also, in the early 1900s, folks could ride what was called the Mount Lowe Railway to the top of the mountain. And at some places, this railway had 48% grade. So when I lived in California and Todd would tell me, oh, look at the beautiful mountains, I was adamant and I would say, these aren't mountains, these are hills. Only the Rocky Mountains are true mountains. But when you get up there, it is really steep, and they are, I will admit, real mountains. Finally, I admit that. Okay, here we go. So additionally, not as far up as Mount Wilson, and before its time, a gentleman by the name of Thaddeus Lowe built Lowe Observatory up on Echo Mountain in 1894. And he was an amateur astronomer. He had a very, very nice observatory, which I don't know if it's still there, but he had a 4-story observatory on Orange Grove Avenue. So if you've ever watched the Rose Parade, it starts on Orange and then it turns up Colorado. Anyway, he had convinced Dr. Lewis Swift to come to California from New York to continue researching comets and nebula. Swift actually dismantled, I believe he was getting ready to retire, he actually dismantled the Warner Observatory in Rochester and reassembled it here. And this is actually a 16-inch Alvin Clark. Now, unfortunately, the facilities were destroyed by a series of disasters. There was a kitchen fire in 1900, there was another fire in 1905, 1909 they had a flash flood which took the pavilion, 1928 saw a gale force wind which actually toppled the observatory. Fortunately, the telescope survived and was later sold to Santa Clara University. In 1936, an electrical fire took the tavern, and in 1938, horrendous rains washed away all that was left of the Mount Lowe breakway.
Wasn't meant to be.
And who says life in California is easy? Nowadays, where the railway stood is a park, and it was just a few blocks away from where Todd and I live. And this is our little pub named Abby. We used to walk there quite a bit. Yes, she's living. Okay, so back to Mount Wilson. So I just wanted to give you a sense of where it is located in the LA area. So you can see right there, obviously that big red balloon is where Mount Wilson is located. Santa Barbara is about 100 miles up the coast, as well as Vandenberg Air Force Base, which I'm sure some of you have heard of because they do a lot of Earth satellites communication and DoD launches out of there. Edwards Air Force Base is just directly north of Mount Wilson up in Lancaster and Palmdale, and that's where they landed the shuttle a couple of times. Todd and I were fortunate enough to see that once. And then San Diego is down south. And there are 3 ways to get up to Mount Wilson. And Steve is smiling because he knows this very well. Steve has actually hiked to the top of Mount Wilson before. So you can take Highway 2 from La Cañada and go up. And JPL is located just right where that freeway, that 210 freeway sign is. And then you can also get to Mount Wilson from Highway 2 going down Palmdale. Hey, thank you, sir. But the funnest way to get to Mount Wilson is along the old toll road here, which I've highlighted in red, or actually scribbled in red. Now, you can't really drive on it anymore because they have it all gated off. And it is a very steep and rough 9-mile 4x4 road. I was fortunate enough to come down it once with the mountain superintendent. His name was Dave Jurasovich, and he owned a first-gen Toyota pickup. Sorry, I don't know why it's doing that. You saw it, I didn't even touch it. He owned a first-gen Toyota pickup, and I think, was it an 84, honey? I think it was an 84. That truck had over 400,000 miles on it, and it was awesome. It was so cool, and he was the original owner. So one day, I actually didn't get to go up with him, but I got to come down the mountain with him on that toll road, and it was so awesome. And I think I was enjoying myself so much that about a third of the way he asked, he said, "Are you nervous?" And I said, "Hell no. I grew up in the back of a Scout in the Colorado high country, so I was not nervous at all to come down that road." So this is the entire complex. It only takes up about 40 acres. You can see, okay, so the solar towers that we are going to talk about, here's the 150 foot, which Jack mentioned earlier, looking at the sunspot drawings today. This is a 60 foot. This is the SNO telescope, and I'll talk about that in just a minute. That was actually the first telescope on Mount Wilson. Here is the grand 100-inch dome. This is the 60-inch dome. This little dome right here is really interesting because there used to be a telescope in there, and they actually did surveys of the moon to see if the lunar surface was safe enough to land on before the Apollo missions. So that one is very historic. And also Jack can tell you more about the new old telescope that has been reinstalled in there. And then there are a couple of silver domes. There's one right there, there's 2 up there, one right there. And those are part of what's called the Char Array. And that's an interferometer which was just built about 15 years ago. So a new 99-year lease was signed in 2003 with the Forest Service. And so just picking off of what Stuart said, The observatory complex really, just being 40 acres, it doesn't take up much of a footprint. But it was really considered the most productive observatory in the world in the 20th century, or I should say the early 20th century. So a short list of the major discoveries to come from research conducted at Mount Wilson were the discovery of the solar magnetic field, the understanding of the structure of our galaxy, stellar interferometry, stellar populations 1 and 2, spiral nebula, their distance and realization that they were other galaxies, the relationship between distance and redshift, the expansion of the universe. However, credit must be given to Slipher at Lowell Observatory in Flagstaff, Arizona, as well as Henrietta Leavitt at Harvard College Observatory. Yeah. So who was behind this amazing place of discovery? It was a gentleman by the name of George Ellery Hale. He was born in Chicago in June of 1868. His father, William, had made a ton of money building and installing hydraulic elevators in Chicago after the Great Fire of 1871. So George was privileged, but he was absolutely interested in everything. An early interest in microscopes led to the building of a small lab in his house. He then developed an interest in optics and astronomy and ultimately stellar formation. And as a young man, his father actually built him a private observatory called Kenwood Observatory, and it's in Chicago. Is it still standing?
I'm not sure. I think so. I'm not.
Yeah, I don't know.
I've heard a little about it over the years.
Well, wasn't part of Kenwood absorbed into University of Chicago?
No, I don't think so.
Nonetheless, it would be nice to have
12
somebody build you an observatory.
12-inch refractor.
Was it a 12-inch refractor?
12-inch per shear, yeah.
For sure. So later on, to top that, his father gave him a 60-inch mirror blank for his birthday. That gives me aperture fever just thinking about it. So he went on, after all of this, to study at MIT and he earned a bachelor's degree in physics. He invented the spectrohelioscope. He discovered solar vortices, magnetic fields of sunspots. He founded the Yerkes Observatory, Mount Wilson Observatory. He built the 200-inch Hale telescope at Palomar. He founded the Astrophysical Journal. He was appointed a fellow in the Royal Astronomical Society. He played an integral part in the funding of Caltech. He convinced Henry Huntington to donate his estate and collection of rare art and books to become the Huntington Library and Gardens. He was very influential in Pasadena and made sure that it would continue to be a scientific and cultural center. So, and that's just the short list of what this man did. So it goes without saying that he was a man full of boundless energy and charisma, but unfortunately, you've probably read, he often suffered from crippling bouts of anxiety, stomach problems, headaches, and just exhaustion. And there were actually years of his life where he was completely bedridden and not able to do much at all. So it's amazing he accomplished all of that. So let's just start by focusing on his contributions to astronomy. So he was the force behind the building of the 4 largest telescopes successfully in the world between the late 1800s and 1948. So one caveat to that is he did, well, I should say before he built the 40-inch Yerkes Observatory, there was another telescope in Ireland, and this is called the Great Leviathan of Parsonstown. And this came online in about 1850 and was technically the world's largest telescope until about 1915. Unfortunately, a lot of its time, it was not productive because it had a speculum mirror. And you can imagine being in Ireland, probably observing conditions weren't all that good. So they had trouble maintaining this telescope. So technically, the Great Leviathan of Parsonstown 72-inch telescope was the largest for a little bit. But let's get back to Mount Wilson. So this is the 60-inch here on the right, and this one we're going to spend a lot of time talking about tonight. But before he built this one in 1908, he built this Yerkes Observatory, and this was a 40-inch Alvin Clark. So as you know, this is a sister telescope to our 20-inch Alvin Clark. They both sat side by side. I'm sorry?
Big sister.
Big sister. So they both sat side by side in the 1893 Chicago World's Fair. This telescope was completed in 1897, and you can see there's a person there on the observing floor to scale. The tube stretches 63 feet. The diameter of the dome is 75 feet. And it was beautiful. So many people turned Hale down when he wanted to build this telescope. He was finally able to convince Charles Yerkes to build it. And my computer is still having problems. That is Charles Yerkes. If he looks like a scoundrel, it's probably because he was. So Hale tried to convince him that if he gave money to science, it would redeem himself, or it would help redeem his reputation. Because he was hated by a lot of people because of corruption allegations, but also because he designed and built streetcars, which killed a bunch of people. So he was not, fondly looked at. So the only way that Hale could convince him, after a lot of trying, was he just happened to let it slip to the newspapers that Yerkes was going to donate money for the telescope. And then Yerkes kind of had to do it. He wasn't happy, but he finally agreed. But he only agreed to build it if this telescope would be larger than the 36-inch telescope at Lick Observatory in Northern California. So can anyone tell me, I know probably almost the whole room can tell me, but can anybody tell me why this was the largest refractor ever built?
SAG.
SAG. So when you build, glass lenses any bigger than this, if it's at kind of a horizontal, or it doesn't even have to be horizontal, the glass, even though it looks like a hard surface, it actually starts to sag. And so that distorts the image that you get from the telescope, because this is the original kind of telescope. So this is the glass lens right here, and the light path goes all the way straight down here to the observing floor. With a reflecting telescope, it's open air here, and the light comes in, reflects off the primary up to the secondary, and then depending on what focus you're looking at, Newtonian, Cassegrain, Coude, it comes out the backside. So because this one, the glass, I don't believe it was sagging, but if they made it any bigger, it would have. Hale got interested in building reflecting telescopes, which used mirrors, which you could support from the structure down here, instead of having it hang off the big structure there. So Hale used the mirror blank from his father. Unfortunately, his father couldn't give him any additional money because he had passed on at that time. So Hale approached Andrew Carnegie, who had given a bunch of money to science at that time. And at first, Carnegie's committee said, no, we're not going to do it. But Hale really pursued him, and finally, he was able to convince him to fund the structure and fund the telescope for the 60-inch telescope. And this saw first light in December of 1908. So he then went on to build the 100-inch telescope. This is 2.5 meters. The movable parts of the telescope, so just this section right here, weighs 83 tons. And this wasn't his biggest one. So we will spend more time talking about this one. But I want to also show this one. So this is the great 200-inch telescope at Palomar. Now there isn't a person in view, but if you can see this tiny little thing right here, that's probably a desk. So this telescope is absolutely enormous. It was the biggest grant given to science at that time. It was $6 million from the Rockefeller Board, and they gave that money in 1928. The telescope weighs 1 million pounds. The glass for the mirror itself was 65 tons of glass. It's 4 times the surface area and 8 times the mass of the 100-inch. And it took the glass mirror a full year to cool before they can even start grinding and polishing. So the mirror was made in New York, and it traveled by train to Pasadena. And my computer just flipped out again. It arrived at Caltech. There was actually an optical shop at Caltech. And unfortunately, this was right at the beginning of World War II. And work had to be delayed. So once they got the mirror blank, obviously Pasadena is on the coast, and they were really concerned about aerial attacks. So they actually covered the mirror blank with timbers, and then the rest of the optical lab was given over to war work. So they were really, really worried about keeping it safe. So when work finally resumed after the war, and the mirror was polished to perfection, it took 5 tons of Pyrex that had to be removed from the actual mirror to shape it. So the Westinghouse plant in Philadelphia built the structural portions. The dome is actually the size of the Pantheon in Rome, and it weighs 2 million pounds. And this was officially dedicated to the Hale telescope in 1948. Sadly, Hale did not live to see his greatest accomplishment. He had died 10 years prior at 70 while this telescope was still being built. And at the time, the local newspapers reported that the priest of the sun had died, that he had passed on. But what he put in motion is quite astounding. So before he built his monster nighttime telescopes that we just discussed, he built 3 solar telescopes. So remember, his first love was the sun. So this is that long building that I showed you before. This is the Snow telescope. It actually was at Yerkes. It was disassembled and then built here at Mount Wilson, and it's named after its benefactor, Helen Snow. Now, when he was looking at a place to found an observatory, he was really struggling. He went to a lot of different places, but ultimately he decided that the Mount Wilson area would be the best because of the amazing seeing conditions, sub-arcsecond at times. So why that happens is because the Pacific Ocean acts like a giant heat sink, and the prevailing winds come over the Pacific and over the LA Basin area in a really straight and laminar flow. So that's why the seeing up there is so good. So originally, this telescope here was covered with canvas to protect the ground so the heat rising off the ground wouldn't distort the image. But in 1911, because they were concerned about wildfires, they replaced it with aluminum. So what happens is the light enters over here and is reflected by the celiostat mirror to another 30-inch mirror, and then it's reflected 100 feet horizontally to a 24-inch concave mirror, and then a slit to a spectrograph in a 15-foot pit, and ultimately what you wind up with is a little image of the sun that's about 6.5 inches across. So it's a lot of work to get that little image. So this, because this didn't work quite as well as he had hoped, he built this first 60-foot tower. And this one came online in 1907. So the light collecting part is up here, so you can see it's way, way, way far above the ground, and so that helps the image. And with this telescope and hydrogen alpha spectrometers, or spectrokilograms rather, he noticed that there were swirls around sunspot groups, and they reminded him of the lines of force and poles around magnets. He also noted that the direction of the swirls would go in opposite directions. And so later this would become known as the Coriolis Effect. So on June 25th, 1908, he photographed also the Zeeman effect from a sunspot spectrum, and this was the first time that magnetic fields were noticed outside of Earth. So this photo was taken from the catwalk of the 100-inch. So you have the 60-foot here, and you have the 150-foot here. Now this one came online in 1912, and a lot of solar rotation studies were conducted by Walter Adams, and very accurate rotation results hinted at the velocity of what is now called supergranulation. In 1914, Hale discovered that the polarities of sunspots in the north and southern hemispheres reversed from cycle to cycle, and the first sunspot drawings began in 1917. And this is one that I just pulled a couple of days ago. So they still continue this to this day. The 60-foot, this one has been operated by the University of Southern California for many years, and the 150-foot was operated by UCLA. Unfortunately, the last time I knew, funding was in jeopardy for both of these programs. So I think Steve Padilla is still continuing doing the sunspots, but I think he's doing it on a volunteer basis. Okay, so let's shift gears to nighttime astronomy. So this is the dome for the 60-inch telescope, and Andrew Carnegie funded this telescope. I think I already told you that. This is a picture, actually, of Andrew Carnegie. Actually, it's a photo of a photo. And he only visited the mountain once. Unfortunately, he was never able to look through the telescope because there was fog and snow that night. So he left very, very disappointed and did not promise any additional money. However, long term, he did end up endowing enough money to fund the observatory through the mid-1980s. But it took some convincing. So the 60-inch was brought up piece by piece up the old Mount Wilson Toll Road by a primitive 1907 Ford truck. but it proved inadequate, even though it said it can handle 5-ton loads. And so the shops rebuilt it, and it still didn't work. And so then they had to have mules assist the truck up the road. Took 500 trips to get everything to the top of the mountain. The massive mounting and steel for the dome were built by the Iron Works in San Francisco. The dome is about 58 feet in diameter. And this is kind of scary, but this is a steel float right here, filled with 650 pounds of mercury. So, and it was only contained in the mid-90s. So before I started working there, you could look down and you could see the mercury floating there. And apparently there were vapors. But that was before it was
a common bearing system for things like lighthouses in those days.
How does it happen?
Yep. So this telescope saw first light on December 8th, 1908, and the first photographs were then taken on December 20th. This was the first major telescope to use what's called a coude focus, by which light can be sent to a really large spectrograph that was not attached to the telescope. In 1909, the program for the world's largest telescope included stellar photography, parallax measurements, nebula clusters photography, and stellar spectroscopy. Photographs and spectra were taken of Halley's Comet in 1910 with this telescope, and those are images of it. So the 60-inch primary mirror is made of plate glass from the Saint-Gobain company in France. And this is the whole mirror right there. You can see that green color. It's actually looking up from the underneath of the mirror, and then the coatings would be up there. So the mirror is 7.5 inches thick and weighs 1,900 pounds. It took 6 months of grinding to obtain a concave surface, and then 2 years to reach final figure. Despite the precautions that they took, and you're all going to cringe, but the mirror was scratched by something when they were in final figuring. Some kind of compound, there was something in the compound that really put a nice scratch on it. So it had to be ground back to a sphere, and then figuring began again. Fortunately, they were able to finish it in 4 months because of their prior experience. So this is a picture of the original clock drive, which regulated the speed of the telescope. Obviously, it's not hooked up to the telescope anymore, but it was neat to come around the corner and see that. And this is just a really pretty picture of the dome in motion during an observing session. A very famous astronomer, Harlow Shapley, used this telescope to study Cepheid luminosity period relationship and to measure the distances to globular clusters. And globular clusters are basically really dense balls of stars that kind of hover around and orbit our galaxy like bees that swarm around a hive. And in 1914, we did not know what the shape of our galaxy was, much less our place in it. So because of the work done with the 60-inch telescope, Shapley was able to plot where these globular clusters were and then figure out where we were in relation to them. And so it also helped us know that, once again, we weren't at the center of everything like we always hoped we would be, like in our solar system. We weren't at the center of the galaxy. We're actually way out here in one of the arms. And basically, this discovery was equivalent to discovering that the Earth goes around the sun, because now we know where our place is within our galaxy. So this is what the telescope looks like today. It's remained very productive over its long history, and right now it is the largest telescope devoted to public outreach. So one of the favorite parts of my job was checking conditions before an observing session. And it was, Mount Wilson is a very, very lovely place, especially when you know the craziness that's going on down in the city. So it's kind of an oasis above the city. So we would check, obviously, for weather, wind, smoke, but we would also monitor particulate levels and pollen levels, so we would protect the mirror coatings. Most of the trees on the mountain are live oaks and Douglas firs, and many of them are 200 to 300 years old. And as you can imagine, there is a fair amount of wildlife. Black bears have been spotted on a regular basis. We had deer up there, squirrels, foxes, bobcats, and at least one mountain lion, which I fortunately didn't get to meet, but one of my friends did. As far as birds, I've seen a lot of stellar jays up there, finches, ravens, and then a friend saw California condor one evening. So this is a picture of me opening the slit before the night's observing session. And much of the observatory still runs on 130 volt DC power. And that is the reason for this braided paneling here. to protect everybody. Above my left elbow, there are 3 original Edison light bulbs. That was really cool.
If they ever burn out, that's it, huh?
That's it. We're shutting down. This is a picture of the old operator's console. So this probably came online in the 40s, and it served us well till about 2005. And this is what the current operator station looks like. So the telescope does have encoders, but everything else is manually done. So whether we are monitoring weathering or weather conditions, rotating the dome, slewing the scope, determining what we look at every night, that's all done manually. So we had 3 monitors. This one right here was used to check weather as well as for me to determine what we were going to look at. And we had to stay within 3 hours of the meridian, because if you didn't do that, the telescope could hit the Newtonian platform, which you didn't want to do. And then we could only go as far south as -23 dec. So there were definite limits on the telescope. This monitor here is the readout for the encoders. And this monitor here is in infrared, and we had a camera on the other side of the observatory, so that's how we monitored guest safety. So the experience of observing through the 60-inch is simply unbeatable. There are times when the telescope is really low to the south. You can kind of see the Newtonian platform right there. So, I mean, we were pretty high above that, but, you still had to be careful. But there were times that when it was really far to the south, that this person would actually have to step off the ladder and onto the telescope to reach the eyepiece. And the first time I was asked to do that, I said, no, that's disrespectful. I'm not stepping on the telescope. And they said, Carla, do you want to look at Jupiter? And I said, yes. So I got over it. It's a big telescope. And even, I mean, you could stand up there and do this. No vibration. Pretty cool. This kid right here, he was the sweetest kid. His name is Ben, and he was going to college, community college up in Steamboat Springs. And his professor, Jimmy Westlake, which many of you probably know, every year he helps these kids run a haunted house for Halloween, and they raise money so they can take a trip to LA and look through the telescope. Ben was awesome. He was the first kid up there that night, and we literally couldn't get him to leave. The bus was pulling out, and he was still up there just looking at the telescope. And I told him, I said, Ben, I've been there, buddy. I know how hard it is to walk away from the telescope, but you've got to get back down the mountain. I can't let you spend the night. But he was a charming kid. As you can see, the barrel, the eyepiece barrel there is pretty big. That's a 4-inch barrel. And so we had to get very specially designed eyepieces in order to fit that barrel. I think we only have 2 of them. So we had students come to the observatory. We had astrophotographers come to the observatory. These pictures are considerably lower tech. I just held my iPhone to the eyepiece. So that's not too bad. Now we actually have an adapter that you can insert it, so it's a little more steady. And these folks, you would not believe it, but this isn't at the beginning of the observing session. This is after an all-nighter, 14 hours, observing through the telescope, and everybody still looks like they're raring to go. So in addition, sometimes people would rent out the observatory for birthday parties, marriage proposals, you name it. We had it up there. Okay, so that's the 60. So this is the 100. The 60 in many ways was the prototype for the 100. Now this photo is beautiful, but interesting too. So can anybody see what's about a quarter of the way down? A fly, I know. This is actually my dear friend and mentor, Kurt Palmer. Before OSHA laws, one of the jobs of the 100-inch operator was shoveling snow off the top of the dome. Fortunately, I never had to do that. I would do a lot of things for that telescope, but I'm not sure I would do that. So, you've seen the outside of this grand dome. Oh, and I should explain, this is the catwalk. So it goes all the way around, so you can go around and check conditions. And there should be a little door right there, but it's too small to actually see. So we've seen the outside, let's take a look at the inside. So the dome is 98 feet in diameter, and the dome itself weighs 1 million pounds. And there's nothing like being there solo and having that 1 million pound dome go around. It's awesome. So The dome and this observing floor are completely separate from the main structure of the telescope in the building, which is right here. So everything moves around the telescope, and that's obviously to prevent vibration. As well as when the wind blows, it sounds like a monster out there just dragging his claws down the side of the dome. So that's why they made sure they kept everything separate. Okay, so this is the famous 100-inch telescope. The picture that I just showed you was taken from up there. I only climbed up there once when I was brave, and I never did it again. In order to build this instrument, our friend, George Ellery Hale, approached a local hardware businessman by the name of John Hooker, and that's why it has the name of the Hooker telescope. And he finally agreed to pay for the production of the mirror. Now, originally, Hale had in mind an 84-inch mirror, but Hooker said he would only fund it if he made it up even 100 inches. So Hale, of course, said, sure, we could do that. $45,000 was pledged for the glass disc, the building for the shop, and the equipment necessary to shape the mirror. But Hale got a little friendly with Hooker's wife.
How friendly?
We're not sure, but friendly enough that the relationship ended and no more funds were promised. So Andrew Carnegie stepped in and gave the remaining $500,000 for the building of the rest of the telescope. So in order to build it, the toll road had to be widened again. During the construction season of 1915, 650 tons of material were transported to the top of the mountain. 4 sections of the tube were too large to travel by train, so they made the trip by ship through the Panama Canal, which you've been through. World War I, once again, delayed work on this project, and Hale was actually so influential in our country that he had formed a scientific council to help President Wilson during the war effort. So he wasn't here a lot of time during the construction. So the mirror is technically 101 inches across. It's 12 inches thick at the edge, and it weighs almost 9,000 pounds. Once again, it's made of French plate glass. If you look closely, I know it's really hard to see, but there are bubbles. Lots and lots and lots of bubbles in this mirror, and it was poured in 3 layers. Took an entire year to cool, 10,000 pounds of glass. When it finally arrived in the observatory shops in Pasadena in 1908, it was actually surprisingly the same day that the 60-inch mirror was being put into the 60-inch telescope. George Ritchie here, who was the chief optician who had polished the 60-inch mirror, opened the crate of the 100 and saw all of those bubbles and said, there's no way this is going to work. It looks like a 3-layer cake. He didn't think it was possible to shape the mirror. So they brought in a glass expert, and that person suggested that the bubbles might actually be beneficial to relieve the strains of the glass during temperature fluctuations. So this was, this was the first mirror that was actually ground by a machine. And Ritchie and Hooker were so against it, but Adams and Hale really pushed on, and they conducted the test on the mirror themselves. So this next slide is for our vice president, all-around Renaissance man. He taught me how to grind and polish mirrors for my own telescope, which I still need to finish. I was really close, and then I got too aggressive one night and dug a hole in it. This is the 100-inch pitch lap. I came around the corner and saw this and about fell over. I couldn't believe that they had saved it. The final curve of the mirror is 1.25 inches deep and required 35 gallons of solution to coat it. So at the time, they were still using silver. They didn't start using aluminum coatings till about 1935. So when they were testing this mirror, the light reflected from the surface onto a photographic plate 42 feet away, and the light focused within 0.006 of an inch with a maximum error of 1 part in 92,000. So it worked. Less than 20 hours of final figuring had to be done by hand. And in 1916, after more than 5 years, it was finally ready. So on July 1st, 1917, the mirror made its long-awaited trip to Mount Wilson. It took 200 men 8 hours, and they averaged 1 mile per hour to bring the mirror to the top. This is actually, oops, I wanted to show you a close-up. Unfortunately, that is not showing. I will show that later. So the Hooker telescope saw first light with a small crowd gathered on November 1st, 1917. The giant tube was turned towards my favorite object, Jupiter. And in Walter Adams' words, this sight appalled them. Instead of a single image, they had 6 or 7 partially overlapping images, irregularly spaced, filling the entire eyepiece. Can you imagine working on this thing for 10 years and then this happening?
Hey, Hubble.
Yeah, that's a low blow. So after some investigation, they finally realized that the dome had been left open that day and the sun had landed on the mirror for a good part of the time. So obviously, you know, the sun on a mirror messes up the figure. So they waited for it to cool to see if it would improve. So Adams and Hale agreed to meet in the dome at 3 a.m. Obviously, neither one of them could sleep, so they came back early. Jupiter was long gone, and so they swung the telescope to a star. I'm not sure which star. I would give anything to know, and I'll have to do some additional research.
I think it was Vega.
Was it Vega? Thank you. So Hale's first look told the whole story. In the center of the eyepiece, the star shone brilliantly, precisely, focused, pinpointed light. So Hale's biggest gamble was a success. There were some post-first light problems. This is at the top of the ladder. Again, that one time I went up there, I took all the pictures I possibly could. One of the first post-light problems was the removable sections of the telescope. So this end part right here, the different cages that you put on, one of which is in the Smithsonian right now, they weren't rigid enough. So they put compression rings around them to try and, you know, just help that a little bit. This picture was taken while standing on the primary mirror cover and looking up at the secondary. So the secondary mirrors, which reflect light, obviously collected the 100-inch mirror to the plates and instruments at the different stations, and they required a lot of precision work as well. So the largest of them, the Newtonian secondary, required over 7 months of work to produce a flat figure, and its final size was 2 by 3. So in order to remove the tertiary mirror, which is this one right there, you actually have to lower this drawbridge. This drawbridge is really, really heavy. And when I was training on the telescope, I had to be able to do it by myself. And I really wrecked my hip because I was determined that I was going to be able to lower and lift this thing. But I just wasn't tall enough to get quite the amount of lift I needed. But anyway, I got it to work. It is still unnerving to stand on the primary mirror cover right there because you know what's beneath you, but it is necessary to remove that tertiary.
Needless to say, that mirror cover is rather sturdy.
Yes, sir.
You bet.
My friend Jim, who I didn't point out, but I will later, is 300 plus, and he could do it. And it was fine. So I was good.
Even
This
I can
photo,
stand on it.
yeah. This photo shows the main gear, drive gear. It's 18 feet in diameter. It was made of cast iron with hollow spokes and made in 2 halves and then bolted together. So tracking errors of greater than 1/10 of an arc second would absolutely not be tolerated. So it was required that the cutting of the teeth of the large worm gear. An Italian instrument maker by the name of Giacomini, which I may be mispronouncing, used a microscope and a diamond scriber to do this. He first divided the gear in 1,440 equal segments for each tooth, scribed the marks, and then inserted a brass ring near the edge of the gear. And he gashed the teeth individually. So there are many, many, many famous astronomers that conducted research at Mount Wilson. You may notice, well, I know you all notice one person here. Einstein visited the observatory in 1931, but this was Edwin Hubble. He was probably the most famous observer to ever work there. He measured galactic distances and speeds to prove that our universe is expanding, which by nature changed our perception of the universe and also led to the theory of the Big Bang origin. This gentleman I
Yeah.
find fascinating because my story is more like his. He quit school. I didn't quit school, but that's... He quit school at the age of 14 and went to work on Mount Wilson in 1905. And he worked in the hotel, and he was a mule driver. In 1911, he married the daughter of the observatory's chief electrician, hopefully for love, not to get closer to the telescopes. But after he married her, all of a sudden he was promoted to janitor at Mount Wilson. So that was a move up. Within a few years, he had become the night assistant, which means telescope operator, and he even began taking some photographic plates himself. By 1924, he had become Hubble's chief assistant, and he used the telescope in the search of variable stars within spiral nebulae. He was eventually recognized with an honorary doctorate degree from University of Lund in Sweden, and just a very, very interesting man to come from such Hubble beginnings.
What was his name?
I didn't even tell you his name. Oh my goodness.
Walter Humason.
Thank you.
Ooh.
Walter Hummingson.
Nope.
Milton, sorry. Walter Adams, Milton Hummingson. There you go. This is Andrew, or excuse me, now I'm almost up. This is Alan Sandage, and he was actually Hubble's assistant during grad school. After Hubble died in 1953, he became responsible for the cosmology program, and he began using telescopes at Mount Wilson, because Caltech at that time helped with Mount Wilson and Carnegie, but also with Palomar, so he worked there too. His primary focus was to carry on Hubble's work and determine the rate at which the universe was expanding. There was also Walter Bade, who was a German astronomer who was interned during World War II for long periods of time up at Mount Wilson. So obviously, I'm sure he didn't want to be confined to Mount Wilson, but he got a lot of telescope time, and it was really dark because they had blackout conditions on the California coast. And this guy is quite a character. His name is Fritz Zwicky, and he worked on the mountain when he wasn't down teaching at Caltech. I've heard he wasn't the nicest of people, but he sure looks nice in that photo. So these are my 100-inch training buddies. The gentleman in the center there, that's Kirk Palmer. He was a senior telescope operator both at Mount Wilson as well as Griffith, and his nickname was Slit Jockey. Jeff Schroeder at the top, he just recently retired from JPL, and this is my friend Jim Mann, who works at Griffith, and then he's also the planetary presenter at Santa Monica Community College. As a side note, Kirk retired a couple of years ago, and he's now living in Florence, Colorado, and he has plans to build his own observatory. So this is a photo taken from the 100-inch catwalk looking to the southeast. You can see the beautiful belt of Venus there. Here we are going through protocols at the operator's desk, and the Newtonian platform is above both Jeff and Kirk's heads. This is the operator's station, so you can see a mixture of both old and new equipment. We did have a radio to keep us company, but it depended on where the dome was pointed to which station you would get. So usually we would just turn it off.
Metal dome will absorb radio waves, yes.
So if you take a close look at this ladder here, I'm not sure exactly what happened, but as we were training, this was a constant reminder to be very, very careful. And in the dome, an inch is a mile sometimes.
Is it not supposed to be bent?
Nobody would come clean as to how that happened. This is the original console. So it's just beautiful. Beautiful, beautiful. These photos show the controls on the Newtonian platform, so that would be used to raise the platform up and down, as well as open the slit and close the slit. I can't remember how wide the slit was. I want to say maybe 15, 20 feet, and it took almost 2 minutes to fully open, and then 2 minutes again to close. So at the time of our training, you couldn't visually look through the 100-inch telescope, so we used this 12-inch finder to see what the 100-inch was on. Which brings me to our method for aligning the telescope. Tell Rad. A $40 plastic Telrad. So basically what a Telrad is it's kind of like a rifle spotting scope. And so I remember one time I was down there and the telescope computer system was really, really old and awful, and it kept barfing. That's a technical term that Kurt had coined. And so I was down there and I was trying to realign it. So I had it on Vega and I was underneath the telescope, and the Telrad is probably, you know, another 5 feet above me, and I was down there like this, trying to get the telescope pointed just right. And the visiting scientist came out and said, "What the hell is taking so long?" And I said, "Well, I'm having to realign the telescope and recalibrate the computer system." And he said, "I don't understand what's taking so long." And I said, "Do you know what a Telrad is?" "No, I don't know what a Telrad is." I said, "Come here." So I showed him, I said, "See that thing right there?" I said, "Stand right underneath here and look up, and I'm trying to get those red circles around Vega." And he said, "Okay, bye." And after that, he was really nice. He gave me all the time I needed. And then as soon as I got it recalibrated, the computer system barked again. This is the old adaptive optics equipment, which was installed in the mid-90s, and I believe it's since been replaced. Minimal maintenance really needs to be done to the telescope prior to an observing session, but occasionally we would have to lubricate the tangent arm on the yoke. If this needed to be done, but you had overlooked it, there would be a horrible, horrible foghorn noise, which would persist and scare the hell out of everybody. So that is me. I know it's hard to see, but that's me up there hanging off the telescope trying to oil that thing. It is always fun to be up and close personal with the telescope. And one of the other things that's important to check is the Jesus indicator on the mercury float, because if you don't check that, I guess there's a bump in the south float and it sounds like a jackhammer underwater. So fortunately I avoided that little competition.
Jackhammer underwater. Oh.
Yeah. So this picture is also helpful because you can really see the English yoke, and this is north. And so the limit we had for this telescope for the 100 inch was 59 degrees deck. So you could never look at Polaris with this telescope. This is affectionately known as the death limit. So the furthest south you could put the telescope was about -15 deck. At this time, the telescope in 2007 was being lowered over the Newtonian platform to put masks on for a run by the U.S. Naval Observatory speckle observations of double stars. And Gale Gant, right here, is my dear friend. He is a retired electrical engineer, and he has devoted literally thousands and thousands of hours of work hours on the telescope, hosting both public night sessions. He designed and installed the encoder systems, weather stations on both telescopes, as well as many, many other projects. So Gale is fascinating for a lot of reasons, but my favorite reason is he saw the Apollo 11 launch from a site that was not, he didn't have clearance to be there, and he said it was way, way too close, and he would never do that again. But I remember one night when we had a client there, and they were, you know, occupied, and they were looking through the telescope. I told him, I said, "Gale, tell me the story again about seeing the Apollo 11 launch." And he did, and I said, "Man, you saw a Saturn V launch." And he was a humble man, and he just looked over at me and he said, "Carla, I saw the Saturn V launch." I said, "Yes, you did." So this is what it looks like during an operating run. Obviously, before, you know, we turn off the white lights and go to red lights only.
Oh.
So a lot of you have been to visit me in California.
Show some leg, are you, Jack?
Jack came, Joe came, Dave came. So Jack brought some classmates up to Mount Wilson a couple of years ago, and we had a wonderful time. And he taught me a bunch of stuff I didn't know. But he had a really good look at these periscopes here on the main console, and we found out that those led to prisms underneath the data room and the mercury flotation chamber to read the hour angle and the deck setting circles on the telescope. And that was super cool.
Yeah, that optical system is amazing. It's got to go under that console, over to the bearing, down behind the bearing, and then there's a swing kind of thing in there, so as the telescope moves, it swings that. It goes across, up, over, up, and that you see that tube that's kind of off to the side? Right between there's a setting circle. And you look through one of those eyepieces, you can see that setting circle. And the other one
You
looks
mean-
down under the floor.
you mean some light
above the,
actually gets
hour
through all that?
circle.
You wouldn't think so, but it does.
You mean some light actually gets through all that?
It's amazing, yeah, it really is. I think, what did we figure, there were something like 15 surfaces or something in
Yeah,
there?
it was
And
absurd.
none of them were coated, so I think they've got a really bright light up there in the circle.
So the observatory structure, obviously you can see from the outside of the dome, is pretty large. These are the concrete buttresses from the ground floor, and you know you're a total geek if you're taking pictures of this kind of stuff. But the pier stands 33 feet high. Like I said below, it's isolated from the rest of the building in order to prevent vibrations in the instrument, as well as when the dome was turned and the wind blew. The hollow structure of the pier, there are actually a bunch of dark rooms and storage areas and shops. So the entire building is 3.5 floors high. And as a child, I'm sure neither of my parents knew this, but I sort of obsessively counted things, and stairs were my favorite thing to count. I don't know why, but I thought in an emergency situation, it might be good to be able to get down the stairs in the dark. Little did I know, I'd been training to be a telescope operator since childhood. So there are 3 sets of stairs. This is the first one, and it is 24 stairs, so 24 hours in a day. The second set, that you can barely see right up there, is 15. So if you take 15 times 24, 360 degrees, full circle. The third set, that kind of arcs up here that goes to the bull ring, is 13. 13 is the diacal constellations. So 24 plus 15 plus 13 equal 52 weeks of the year.
Todd's away a lot, isn't he?
What?
I said Todd's away a lot.
But you need to know this stuff when the lights are out, so you can count and you don't fall.
Oh, okay.
Yeah.
So if you see where the red arrow points at the end of that second staircase, this is what we call the 100-inch Hilton. So in the hollow structure of the pier, this is a former dark room, which we converted into living quarters for ourselves. And it was really nice. We had a sink, we had a microwave, you had a futon, you had a desk, and even a little fridge. So that's where we slept. We got to sleep right underneath the telescope. So the building was constructed using hot rivet structure, so basically built like a battleship. Very cool. This is the original main drive motor, I think. Correct me if I'm wrong, please. That's what my notes said. I could be wrong. This is the governor on the left and the gravity clock drive on the right, which went down a really deep pit. And then my dad will appreciate this slide. This is the electrical panel on the ground floor. 1917 style.
That's a rheostat.
So all in all, it's really easy to see why this amazing facility was designated as an international historical mechanical engineering landmark. It was a workhorse for many of the great astronomers of the last century, and the great discoveries made with it and the massive important data collected for more than 60 years made the 100-inch Hooker telescope one of the most important scientific instruments of all times. Research is still being conducted at the telescope. I worked on 2 projects. I worked on a Jupiter seismology project. And this is just a picture of my monitor, trying to keep Jupiter in focus there. And then I also worked on confirming a few exoplanets. The telescope is also used frequently for movies and TV spots, one of which was a Budweiser commercial a couple of years ago. It played during the Super Bowl. Now, what these scientists were doing is they were looking for an asteroid, and supposedly this asteroid was going to destroy the Earth. How many times have you heard that? So they were trying to determine the level of doom, and when they had discovered that all hope was lost, they broke out the Bud Light and started riding the telescope like a bucking bronco. I was so mad.
I saw that too.
Because I love football, so I'm like, oh, Mel Wilson's going to be in the Super Bowl, it's going to be so cool. Riding the telescope like a bucking bronco. I don't care if it's the end of the world, you do not do that. Honor the telescope.
No slim pickings.
So they're working on a new control system and a very, very complex optical system, thanks to my buddy Gale. And it's being installed to allow easy access to being able to actually view through the 100-inch telescope without climbing way up on the Newtonian platform and risking life and limb. So if anyone wants to plan a trip to California, we can look through the 100-inch now for probably $300 each, which I think is well worth it.
Each look.
No, not each look, for a full night. And I heard the central star in M57 is blinding.
What's that?
The central star in M57 is blinding through the 100-inch. So Mount Wilson is so rich in history that it's literally impossible to take a walk without stumbling on a treasure. This is a survey marker notating the location of a historical experiment. It was the exact location to one of Albert Michelson's first light studies. As a side note, he was the first American scientist to be awarded the Nobel Prize in Physics in 1907. He was from the University of Chicago, and he came to Mount Wilson in 1919, and he kept coming for many years as a guest investigator. So his experiments that he made at Mount Wilson helped us determine the speed of light. And this was before lasers and modern electronics. So he used determinations going from Mount Wilson to Mount San Antonio. And he yielded a very close value to what we now know today. So there are just piers everywhere, all over the mountain. Sometimes you know somebody who can figure out what they were, but oftentimes they're just standing there. Or they're, just still there. This was that original dome that I told you that they used for pre-Apollo surveys. It was also used for an infrared galactic plane survey. So there are a few newish projects. One is called the Char Array. It is a Center for High Angular Resolution Astronomy. That is a mouthful, and it's run by Georgia State University. It is basically world-class and provides the highest resolution of any telescope at visible or near-infrared wavelengths. This is what it looks like. So you can see it's kind of a Y-shaped structure that spans the entire top of the mountain.
Could be LA.
Yeah. It consists of 6 1-meter telescopes.
Carla, is that operated in infrared or invisible?
Both. Near infrared. The 6 lines from the telescopes come in parallel to preserve the polarizations. And this is the beam management subsystems. I have friends that work at Chara. I don't have any direct experience with it, but it looks pretty darn impressive. So among its firsts are the first detection of a gravity darkening by a single star, which was Regulus. The first image of a binary star system in eclipse, which Dr. Stencil, I believe, was one of the principal investigators on. The first detection of a hot exozodiacal dust around a main sequence star, being Vega. The first model independent measurement of an exoplanet diameter, and the first direct image of an interacting binary. They're doing good work. So none of these discoveries would be possible without a good, strong infrastructure at Mount Wilson. In its heyday, there were probably between 25 to 35 people that worked on the mountain. This is only a small portion of the machine shop and the belt, drives, and everything still works. It's amazing. This was the first generator on the mountain, I believe in 1910, and then the second one on the right, 1911. I'm not sure why they needed to replace it so soon, but they did. And when the astronomers were working, they could hear these generators working, and so they would run down to shower in the steam that was coming from them in an adjacent room.
Those are steam-driven, Carl? Is that a steam engine there?
Mm-hmm.
And they're generating DC voltage?
Yes, 130 volts. So almost everything on the mountain is a work of art in one way or another. It's just amazing. So this is a view looking towards LA in the morning after I woke up, looking towards Mount Harvard, which is this kind of prominent peak that sticks out right there. You can see the city below covered in clouds, so it must have been a really good night because we had dark skies. There are cottages and houses scattered all over the mountain. So this building here is where the 100-inch operators would stay before we stayed at the 100-inch Hilton under the telescope. And then this cottage, it's really hard to see, but this is Capetian's cottage right there. And he was a Dutch astronomer, and he built that so his wife could come and stay with him. And it still stands there today. And I think he charted proper motions of stars. This is, when we weren't staying in the Hilton, this is where we stayed. So this is the monastery. So there are approximately 15 rooms for telescope operators, session directors, students, visiting astronomers. The day side is on the left. So what that means is the day side were day sleepers. So you worked at night. And then this side is the night side. So you worked on the solar telescopes and then you slept at night. So you can see this is nice and bright and light. Where these, we had these huge metal shires to bring down so we could actually get some dark to sleep. This is the hallway leading to our quarters. And it's called the monastery because of the monastic kind of routines that the astronomers and the workers, would adhere to conduct their work. So that's what we
back
call
in the day, it was all male also.
Fortunately, I wasn't born back.
Yeah.
So these were some of my quarters. So obviously more than adequate. I had a desk, a bed, chest of drawers, and a sink. And my cousin Brian will like the tiger. That's right.
The tiger.
There were bathrooms and showers and laundry and a mini kitchen down the hall. And in its heyday, there was actually a couple that this was the kitchen area, and there was a couple that would live in that room, and they were responsible for catering to everybody's requests. There is a library, and there is a nice picture, painting rather, of Andrew Carnegie, our benefactor. And this is looking the opposite side of the library. So George Ellery Hale was also an avid botanist. And if you look through some of these books, you can still find his pressings of flowers and plants that he found on the mountain. So you have to be very careful when you open them because you don't want them to fall because they're almost 100 years old.
He did that in his spare time, right?
Yes. You'll probably recognize a few of the people here. Ooh, that's a bad photo. Resolution didn't hold. Anyway, this is Einstein. And apparently this is still the chair that we have that he sat in. It's a Stickley. Not many people sat in that chair. It's just weird to sit in the place that Einstein had sat. This is the dining room. The chief observer always sat here, so more often than not, that was Edwin Hubble. The 100-inch operator would sit here. A visiting astronomer would sit over here, and everybody had their designated spots, and you knew where your spot was according to your napkin ring holder that was in front of your place. And it's reported that Hubble would go into the adjoining library and read up on a really, really obscure topic, and then at dinner just quiz people for the fun of it. And he was a little egotistical, so I imagine that wasn't much fun. Harlow Shapley that I mentioned before, the one that helped us figure out where our place was in the galaxy. Obviously, I told you he studied globular clusters, but this is a portion of his photographic display that's still there in the dining room.
Did Shapley do that work on the 60-inch or the 100?
The 60,
the 60
primarily. And this is a view of the monastery shortly after sunrise. It is such a gorgeous place up there. And a lot of the funding to the mid-'80s was from Carnegie, but then after that they started directing money to Chile, and so Mount Wilson was kind of left to the wind. And so they founded a nonprofit organization in 1986 called the Mount Wilson Institute, and they continue to run the observatory today. So this is a living treasure. His name is Don Nicholson. He was the son of famous Seth Nicholson, who was a very interesting man because he had discovered 4 moons of Jupiter and stopped because he didn't want to outdo Galileo.
Oh.
So the guy had a lot of character. Don basically grew up on the mountain, and he assisted with public nights, during the golden years of the observatory. He remembers when the Michelson light studies were being conducted and the horrible sounds that were emanating from that machine. He met many of the visiting astronomers and physicists, and he has just been intimately involved with all observatory operations during his life. He's 95 years old now, and he lives in Altadena, where Todd and I lived, and it's basically about 4 miles from Mount Wilson as the crow flies. He's just a neat guy. So unfortunately now it's time for me to switch gears and tell you about a few of the darkest days of the observatory and when we almost lost it all. So this is the Azusa fire. It started in August of 2009. It turned out to be just a 200-acre wildfire that scorched brush. This is a view from the 150-foot solar tower cam looking down on the fire. Fortunately, they were able to contain this one relatively quickly, but that night I was working at Griffith and I was checking conditions to make sure it'd be safe to open the Zeiss telescope. I was looking for ash, and I was worried about this fire, obviously, but further to the left, I spotted what looked like another little fire starting. And it looked really small and isolated and maybe just like a small house fire. I was wrong. That was the beginnings of the station fire, which ultimately burned over 160,000 acres, threatened the cities of La Cañada, Flint Ridge, Altadena, Acton, Sunland, and Tujunga. Ultimately burned 209 structures and claimed the lives of 2 firefighters. Anybody know what that is?
Yeah.
That's JPL. So JPL was almost threatened too.
They closed down and had a fire day where it rained ash on the lab.
That's before I worked there, but I've heard about that. That photo just still sends shivers down my spine. So by August 30th, it had spread and was dangerously close to Mount Wilson. These are the towers that you can see in the background. September 1st, we thought all hope was lost. The entire observatory was under attack. This is a photo from the LA Times showing the pyrocumulus cloud. There's so much smoke in the air you can't even see the mountains. And it had only gotten worse, and so they finally brought in a few hotshot crews, one from Helena, and I can't remember where the other one was from. And there are so many stories of these brave men and women that I can't even do them justice, but there is a lot of information on the Mount Wilson website. So almost a week later, they did a preventative burn, and that was really scary because they were worried that it would rush up the mountain, but it didn't. Situation was still very tenuous. So it wasn't contained for 7 weeks. And this is what it looked like driving up later. It looked like the moon. It was ruled arson by a fellow firefighter. And it's rumored that he was worried he was going to lose his job because of funds being cut, and so he started this fire. So when it was all said and done, 252 square miles were burned, and it became the 10th largest fire in California history. So fortunately, Mount Wilson was very well prepared. We had a 1 million-gallon water tank. They had done a lot of brush clearance. They had updated equipment. And with the hotshot crews and the pilots attacking from the air, it was saved. There were still hot spots burning, and until we got our first snow in December, they weren't completely out. So, despite the massive amounts of light pollution in LA, which Jacob is actually studying from below this area, just a little bit, another form of pollution. The magic of Mount Wilson lives on and endures in the hearts of all of us who have worked there or visited there. It's a really special place like none other. In summary, I never ever met a telescope I didn't like. Art Clark will always be my first love. The Zeiss telescope at Griffith will always be deeply loved because that was my first paid astronomy gig and the telescope that I probably spent the most time with. The 60-inch was an absolute honor and pleasure to use. It was the easiest telescope I ever learned how to operate. But the 100 was, I mean, it was intimidating. The telescope was usually very well behaved, but that computer system made it really difficult. It took a lot of energy to operate that telescope. You were just running around and you really got to work out. But I must say, despite this intimidation factor, when it comes my time, and before my soul escapes the bonds of our planet, the last man-made structure I will think of will be this. It is my cathedral, my dream come true, and my absolute honor. Thank you. Jack can attest to how good this book is, The Day We Found the Universe. It's wonderful. There's also a walking tour of Don Nelson, who is our living treasure. And there's also PBS Doc, which is really good. And then there's also California's Gold episode, which you can get as well. Additionally, the Huntington has blueprints and engineering drawings in their digital archive that you can check out. So thanks. Anything else?